point. Angular momentum is always calculated about some point. A point or an axis should be given to calculate the angular momentum. For example, first I will write what is angular momentum. Angular momentum is L vector is R vector cross P vector. R vector is the radius vector or the distance vector, displacement vector, and P vector is the momentum vector, linear momentum vector. And this angular momentum is also known as moment of momentum. This is also known as moment of momentum. Moment of momentum. Like you have seen, there is one more term. There is one more term you have seen, moment of force. Moment of force is what? Torque. Moment of force. Moment of force. Moment of. Okay. Okay. Hello, Divyangi. I'm audible. So moment of force is basically what? Torque is the moment of force, and what is torque? Torque vector is equal to R cross F. Similarly, the angular momentum is R cross P. Okay, torque is R cross F. Moment of force and moment of momentum, that is angular momentum, R cross P. R cross P. Okay, and what is P? P is the linear momentum here. P is the linear momentum. P is the linear momentum. Linear momentum. L is the angular momentum, R you know, and this is a vector quantity. This is a vector quantity. This is a vector quantity. Now, angular momentum can be written in some other form also. For example, angular momentum is given by L is equal to R cross P. Na? Angular momentum is, I told you, R vector cross P vector. So now, what is the value of the P vector? I told you, M into V vector. M into V vector, na? P vector, linear momentum vector is equal to M into V vector. So I can write, instead of this P vector, M into V vector. So it will become R cross M into V vector. Okay, R vector cross M into V vector. So finally you can write it as M R vector cross V vector. So this is another form of linear angular momentum. M R vector cross V vector. This is another form. R cross V vector. Now I told you that if I am writing A cross B, A vector cross B vector means one vector cross another vector. So it can be written as AB sine theta, AB sine theta and n cap also. So I'm talking about the magnitude. So that is why I'm avoiding n cap. So A cross B can be written as AB sine theta. In the same way, when you will open this L vector, this will be M This will become r into v sine theta, r into v sine theta, or you can write it as r. Uh, Sorry. You can write it as m into r sine theta into v, r sine theta into v. So what does it means? You can see here. So m into r v sine theta. V sine theta means the perpendicular component of the velocity. If the velocity is in this direction, if the velocity is in this direction, okay, and making an angle theta with this direction, so this is the perpendicular component of the velocity. Perpendicular component of the velocity in this direction, there will be the parallel component of the velocity. Okay, if the velocity is like this about any point, then this is the perpendicular component of the velocity, and this is known as the parallel component of the velocity. So you can write m into r into v perpendicular, or in terms of r sine theta, you can write this r sine theta. If suppose this is r, okay, and this is theta, so this component will be r sine theta, and this component will be perpendicular component of r. So you can write r m into r perpendicular into v. You can write simply mv into r perpendicular. So according to the requirement, we will use this formula. According to the requirement, we will use this formula. So I will solve numerical, then you will understand. Okay, when we will solve numerical, then you will understand. Okay, and what will be the unit of angular momentum? So unit of angular momentum can be calculated with this formula. Any of the formula you can take. So in the expression of angular momentum, there is mass, there is radius, there is velocity, and there is no angle with this. Means there is no angle of what I'm saying. There is no unit of this sine theta. This is unitless. So m, the unit of mass is kg, and unit of radius is unit of mass is kg, and unit of radius is meter, and unit of velocity or speed is meter per second square. Meter per second square. So unit will be kg meter square divided by second square. Kg meter square divided. This is not second square. This is second. Okay, meter per second. So it will be kg meter square second. So this will be the unit. I am talking about the SI unit. Okay. So this is the angular momentum. Okay, so first note down, then we will take one example, then you will understand. Please note down first. Done?
Done, sir.
Okay. 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 So now we will take one question. Suppose this is mass m, and this mass m is moving with velocity v. Okay. And there is a point here, point O. Point O is there, and this is the horizontal direction. And with the horizontal, this angle is theta. This angle is theta. Okay, so a mass is moving with velocity v in this direction, and we want to find the angular momentum of the mass with respect to the point O. Angular momentum of mass m with respect to point O. Okay, with respect to point O. So if we want to find the angular momentum, so how we will find the angular momentum? Okay. So if you want to find the angular momentum, so either you should apply this formula, m into r into v perpendicular means r means this r and v should be perpendicular. And what is r? R is this distance. This from O to M distance is small r. Okay, this distance is r distance. Means the point O and where the mass is present is r basically. Okay. Now this is r. Either you should take the perpendicular component of r, or you should take perpendicular component means the component of velocity with respect to r. Okay, so what I am doing here in this case, I am just taking the perpendicular component of r. So perpendicular component of r will be this. This will be r sine theta, and this will be r cos theta. This is suppose this point is A, and this point is O, and this point is B. So OA is equal to R, we know. And now AB is equal to R sine theta. And what is your this R sine theta? R sine theta is R perpendicular, and R cos theta, that is OB. OB is equal to R cos theta. R cos theta is parallel component of R. So what is the formula of angular momentum? M V into R perpendicular. So apply this formula, you will get the answer. M V R perpendicular is R sine theta. So this is the answer. Direction I will tell you later. One more way to solve this question. Okay. Now this is the velocity. This is the velocity, na? So we can take two components of velocity. One is the perpendicular component of the velocity. Perpendicular component of the velocity means perpendicular to r. Perpendicular component of velocity means perpendicular to r. So in this way, you can take the component of the velocity now this time. So perpendicular to r, one component, and this component will be, for this component you have to calculate this angle. Okay, with respect to angle you have to calculate the component. I mean this component will be the perpendicular component. Okay, whatever will be the angle, but this component will be the v perpendicular component, v perpendicular. Okay, and there will be another direction, means in this direction this component will be parallel component, parallel component of the velocity. Okay, so we can, if this angle is theta, see this is horizontal, this is the same line. If this angle is theta, this is horizontal, this is the same line. So this angle will also be theta. If this angle will also be theta, so this component of the velocity will be v cos theta. So another component will be perpendicular component. This will be v sin theta. V sin theta. Now you can, and this will be v perpendicular, so you can find the angular momentum m into v, m r into v perpendicular. M r into v perpendicular. So m r, what is v perpendicular? V sin theta. V sin theta. Check both the answer. MVR sin theta, it is also MVR sin theta. So in both the ways, by both the ways, we will get the same answer. Okay. But depending upon the question, we will do a further question, and we will see there the convenient method we will use. Okay. From the easiest one we will use depending upon the question. Sometimes this one will be taking the component of r will be easier for you, and sometimes taking the component of the velocity will be easier for you. So accordingly we will see. Not talking about the direction, talking about the direction. 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 So direction is simply, this is the axial vector, and I told you all the, for all the axial vectors, the direction is given by right hand thumb rule. right hand thumb rule. Okay, my video camera is not working, so I can just show you. But I told you earlier also, so you can take help of that right hand thumb rule. Okay, right hand thumb rule. So right hand thumb rule means we will use our right hand. Means point out your finger along the direction of the one vector and curl your finger to the another vector, and the direction of the thumb will give you the direction of the resultant vector. So here na, what you have to do, you have to apply the right hand thumb rule. And how to apply the right hand thumb rule, I told you earlier also. I think in the torque, I think I told you. No, here in the circular motion. I think I have already written the uh, statement for the right hand thumb rule somewhere. Okay, leave that. So right hand thumb rule. So how we will find the direction? So this will be given by always R cross V, given by R cross V or R cross P. So R cross V you have to do. Means you have to point out your fingers towards the radius and curl toward the velocity vector. For example, in this case, this is the radius. So first you should do now. What you should do? You should extend this. Okay, so this is your direction of R. This is your direction of R, and this is direction of the velocity. So just uh, point your point out your so first take your right hand and point out your four fingers towards the radius, towards this R vector, in such a way that uh, curl your fingers properly along the velocity, means in this direction, like this, clockwise you will curl your finger. So when you will curl your finger, the direction of the angular momentum will be away from you. Okay, away from you or inward. Here also same way you have to do. R cross V you have to do. So this is your R direction. This direct extend your R. Okay. Uh, this is your V. So this is your R. This is your V. So point your finger towards the R and curl towards the V. So you will get again the direction away from you. That is inward direction. So right hand thumb rule. And so by convention, if one another way, uh, in this way also you can find out the direction of the angular momentum. This is clockwise. So clockwise is represented as inward. Clockwise angular momentum is the inward, and anti-clockwise angular momentum is outward. Okay. So if you can remember this all this, then you will get your answer properly. So here also you will get clockwise. Okay, because R is this. You have to extend this arm of R. Okay, then you will curl like this towards the velocity. This is the velocity now. Okay, so write down this. Then we will solve some of More questions? Okay. Done? Okay. Okay, we will solve some of the questions on this topic. So the question is, a particle of mass m is moving with constant velocity. A particle of mass m moving with constant velocity, moving with constant velocity, parallel to x-axis, parallel to x-axis its angular momentum about origin. Its angular momentum about origin, number 1, 0. Option B, constant. Option C, goes on increasing. And option D, goes on decreasing. Goes on decreasing. So we will solve this question. So there is a particle of mass m is there, and that particle of mass m is moving parallel to the x-axis. So there are two axes. So this is x-axis, suppose. This is x-axis and this is y-axis. And this particle is moving parallel to x-axis, na? They are saying a particle of mass m moving with constant velocity with parallel to x-axis. Its angular momentum about origin. So this is the origin. So the particle is suppose moving like this. This is mass m of the particle and velocity v. Initially this is at point A, and after that this particle is moving and moving and moving, and finally this is at point B, and this is moving with a velocity of v again. Okay, so we will see whether the angular momentum is changing with O or not, whether the angular momentum of particle is changing with O or not. So for that, what you will do, first you will calculate the angular momentum of the particle for position A, and you will calculate the angular momentum of the particle about the origin for the position B. So first we will calculate the angular momentum of the particle for the position A. So for the position A, we will see this is the radius r. This is r. This is the r. This will be the r. No? Suppose this is RA. Now to calculate the angular momentum, either you should take the component of the velocity, or you should take the component of this r. But here, if you will take the component of the velocity, okay, uh, then that will be means for us, because we do not know what is theta and all that, so we will not compare. We cannot compare the angular momentum for the position A and the position B. So this particle is moving in this direction, and we have to check whether the angular momentum is changing or not. So here what I am doing, I am just taking the component of the r. So which component, there is a requirement of which component? Perpendicular component means this component, this value, and this, suppose this is making an angle of theta. Okay, this is making an angle of theta, so it will be r a into sine theta. Sine theta, this distance, na? This distance, r a into sine theta. Okay, now for the position B, now calculate the angular momentum for the position A. Angular momentum about O, angular momentum about O for position A. That will be equal to mass into V into RA sine theta. Okay. Now for the position B, this will be the distance. Okay, this will be the distance, and suppose this angle be some other angle. Suppose this is angle theta dash. This angle will be theta dash. So we have to extend our x-axis. Okay. And this particle is also moving parallel to the x-axis. So for this particle, for calculating the angular momentum, this will be the uh, r, or say it rb. Say this distance as rb distance. This distance is ra sine theta, and this distance is rb. So you will take this component of rb. So this component of rb will be rb sine theta dash, rb sine theta dash. Now angular momentum about o, when the particle is at point v, is equal to m into v rb sine theta dash. Okay, this is not theta 1, this is theta dash. So now this axis and this motion is parallel. I mean, this line, if you will draw a line, this line and this line are parallel. So this line are parallel also, and you can say this distance, will this distance change? Means the distance between point A, and suppose this point is M and this is point N. So AM will also AN, if the particle is moving parallel, if the particle is moving parallel to the x-axis, means there is no change in the y coordinate. Means the y coordinate, this is the y coordinate now. If you will just calculate the this AM, so AM is the y coordinate here. So this AM y coordinate will never change because the particle is moving parallel to the x-axis. If the particle is moving parallel to the y-axis, then x coordinate will never change. Okay. So you can say this RB sine theta dash is equal to RA sine theta. So you can say RA sine theta always equal to RB sine theta dash, because the particle is moving parallel to the x-axis. So you can say the angular momentum about point O at the position A is equal to the angular momentum about point O at the position B. Means the angular momentum will never change. So the angular momentum will remain constant. Understanding? Hmm?
Yes, sir.
Okay. So write down. Angular momentum is not changing because the particle is moving parallel to the x-axis. Okay. Write down. Done.
Done, sir.
Okay, so okay, fine. One more question we will do, that is related to the projectile, means projectile involved with the rotational motion. Same question we will take, the same concept. A ball of mass m is projected uh, with velocity v at an angle of 45 degree. With velocity v at an angle of 45 degree with respect to horizontal. With respect to horizontal. Find the angular momentum of the ball. Find the angular momentum of the ball with respect to the point of projection. With respect to the point of projection. Point of projection. With respect to the point of projection, when ball is at maximum height. When ball is at maximum height. Maximum height. Okay. So there is a ball, and here suppose this is the horizontal, and a ball is projected like this, and means I am showing the path of the ball. Okay, I am showing the path of the ball. The path of the ball will be projectile path. Consider this. Okay, so the velocity here with the ground is 45 degree. This velocity is 40. This velocity is given as v. Okay, they are saying this angle is 45 degree. This angle is 45 degree, and somewhere here will be the maximum height. This will be the maximum height. I am not showing the whole path. You know what will be the whole path. I'm showing just half path. Okay, because with this it is not possible to draw properly. So it will be the whole path. Okay, of the ball. So here the ball is, this will be the point where the ball is achieving the maximum height, h max. And what is the maximum height for the projectile? U square sine theta divided by 2g. U square sine theta divided by 2g. And what is the angle here? 45 degree. So maximum height will be u square means v square. Here u, instead of u it is given, it is thrown with the velocity v. Okay, so v square sine 45 is 1 by root 2. Oh, u square sine square theta by g. Okay, u square sine square theta by g. So it will be v square sine square 45. Sine square 45 divided by g. It will be um, hmm. It will be, sorry, it will be 2g. U square sine square divided by 2g. So it will become v square sine square 45 means sine 45 is 1 by root 2, and 1 by root 2 square means 1 by 2, and 1 by 2 is multiplied by 1 by 2. becomes 1 by 4, becomes 1 by 4. So it will become v square by 4g. Okay, it will become v square by 4g. So this height will become v square by 4g. And you want to find the angular momentum of this point. Okay, so for that there is a requirement of this r, this angular momentum. There is a requirement of angular momentum of the ball, this ball having the mass m, about the point of the projection. So here suppose O is the prime point of the projection. So the perpendicular distance, okay, or perpendicular component of this r is h max. Okay, perpendicular component of this r is h max. So r perpendicular here is h max, that is v square by 4g. Okay, v square by 4g. Now we can find it easily. We want to find the angular momentum. So angular momentum is equal to m v into r perpendicular. So m is m, v is v, r perpendicular is v square by 4g, v square by 4g. So it will become mv cube by 4g. So this will be the answer. Because this r perpendicular is v square by 4g. Okay. So mv into r perpendicular will be the angular momentum, okay, about this point. Just a minute. Okay, 1 minute, 1 minute. Actually, na, I'm doing one mistake here. Actually, here na, at the highest point, here the velocity will be only v cos 45. V cos 45 only at the highest point. Okay, if you will take the component in this direction, the velocity component will be v cos 45, and in this direction the component of the velocity will be v sine 45. So this sine 45 will change due to the gravity, but this v cos 45 will never change. So here the velocity component will be v sine 45. So instead of this v, we will take v sine cos 45. Okay, so m into v cos 45, v cos 45, because v cos 45 is perpendicular to h max. Okay, so multiplied by h max, that is v square by 4g. Now we can solve it easily. So it will be m v cube divided by 4g and multiplied by cos 45, that is 1 by root 2. So it will become mv cube divided by 4 root 2g. So this will be the final answer. Okay, this will be the final answer. So what you have to do, the ball is here and you have to find they are asking when the ball is here, find the angular momentum about this point. So when the ball is here, what is the velocity of that ball here? That is v cos 45 only, because at the highest point there is only horizontal component of the velocity, no vertical component, because the vertical component becomes zero due to the gravitational force, or the due to acceleration due to gravity. So at this point the velocity is this, and this distance is maximum height, and in angular momentum there is a requirement of r perpendicular and the velocity. So this is the r perpendicular and this is the velocity. Okay, so v cos 45 is the velocity and this is r perpendicular, and multiply it with mass, you will get the angular momentum. Okay, write down. This is a good question, I will say.